Hello 108 students, Mr. McHugh here with you on our bonus or extra credit pages of application problems on page 5 for section 10.6. And example number 6 is my example number 6 course almost corresponds with the one in the book, which is on page 616. And the only difference here is that on the rate of the problem, the book example uses 3%. Okay, so what we got going on here is they go, how much money will there be in an account at the end of 5 years if $1,000 is deposited at for me 6% in the old version of the book, compounded quarterly, assuming no withdrawals are made. Okay, so this is not a bad application problem here. This is a good one for investment purposes. So quarterly, you might find at your bank they'll have, like, they used to have passbooks or saving book accounts that they're going to pay quarterly. If you put $1,000 in for principal, the rate in my example, so I'll follow this, is 6%. Quarterly means what? 4 times a year. Okay, that N is by how many times per year. T is 5 years. Does that match the same here? Yep. And A, how much money will you have in the account at the end of 5 years? Okay, so in a way this is a plug and chug problem. You just have to get your variables, understand what they mean, and you're going to find what A is. How much is at the end of the account? If I say CD, I mean certificates of deposit. This is one of the safest and quickest ways to take some of your money, invest it into a certificate of deposit, and the bank will pay you such as 6%. You agree to keep it in there for 5 years, and you're going to put $1,000 in. How much will you have at the end of it? So let's see if we can figure it out. Okay, so you got your calculators with you. You turn around, write the equation. I wrote sideways here, but plug in 1,000. 1 is part of the equation. Rate was 0.06. Notice it's in percent. N is how many times per year it's compounded, and that compounded, by the way, means how many times they're going to calculate that interest and then add it to your account. So everybody see, you go a certain period of time. Every quarterly means what? Three months. They're going to calculate how much interest you've earned and then put it into the account, and it keeps getting bigger and bigger and bigger. That's how you make money. Okay, N times R in the exponent. And again is 4 times a year. How many years? 5. So there's 20 installments of the payment system going on. Okay, so turn around. You got, reduce this down. 4 times 5 is 20. 0.06 divided by 4 is 0.015. Add the 1. Use your calculator. Raise it to the 20th power. Multiply by 1,000, and bingo! You find out that you have got a total of $1,346.86 in the account. Okay, now, funny thing is, of course, you know there was $1,000 is what you invested. So how much money did you make? $346.86. Okay, I love teaching these problems, and maybe with the videos it gives me a chance to kind of say stuff I usually don't get a chance to say in classrooms. But so you took $1,000, you were willing to let it sit for 5 years, and you made $346.86 at the end. That's the smart way to make money. What I mean by that is, I'm used to, most of us are into, we owe so much money, we got bills, we never save up. But if you could save up $1,000, or if you had an opportunity to get $1,000 from an inheritance or something, instead of spending it, putting it into a fairly safe investment that you know you're not going to lose your money, you would have $346 that left at the end. Okay, so that's the idea. And as you can see, my spill here is, how much money did you make? I've already answered that, and you can see that's the amount. A was the total amount that you have in the account minus the principal that you put in, that difference, interest made. Okay, so let's keep cruising here. Let's go through these problems fairly quick. Example 7 in my notes is the same as the book, and so that happens to be on page 617, FYI. And so if you look at this example, it says, I suppose inflation is averaging 3% per year. And I like these questions and getting into it, because you wonder why your money seems to go less and less, because if you don't get increases in your salary because your boss telling you economy's tough, and then everything keeps going up in prices, so your purchasing power keeps getting diluted. So think about this here. Suppose inflation is averaging 3% per year. That means the cost of everything goes up. So if I used to say a loaf of bread was $1, which it isn't anymore, but pretend it would be, it would now cost you 3% would be 3 cents on it. Would now cost you $1.03. You know what's funny for me? I just side note. Over the years, you'd go and grocery shop, and my mom, this is way back when I was growing up in the early 70s, would go by for a family of 9 people, go grocery shopping weekly, and spend $50 on groceries. Now we go out there to Fred Meyer's, and my wife and I buy a grocery cart full of groceries, and I can expect that to be a $200 bill, and it just blows my mind that it's quadrupled the price and over the prices over the decades. So just a crazy world we live in. So inflation is a big factor of that. Okay, so this question asks, we want the number of years T for the dollars to grow to double. So at rate of 3%, we want to figure out how long, approximately the time it will take for the prices to double. Okay, love these questions because I've just kind of answered myself, how long did it take for it to quadruple, and I say 30, 40 years. So, okay, so we take this example here. The key thing here is realize P is, they're going to use $1 to start with. Now, how long will it be for A to double? That's the doubling part. D-O-U-B-L-A. Okay. How much time? That's what we need to figure out. Okay, and the interest rate at the end, number of time of compound is once per year. That was given to us. 3% interest is 0.03. So, kind of like plug and chug, and so you plug in the values, you can kind of see here, but guess what we're finding? T is up in the exponent. Ooh, that's a little tricky. So, you could see the substitution coming in here. You could see the arithmetic, 0.03 divided by 1 is the same thing. 1 plus 0.03, 1 times T. Okay, so now we got down to 2 equals 1.03 raised to the T, which is time. Okay, now, how do you solve this? So here's where the problem really starts. You substitute in, you reduce it all down, and you take the log on both sides. That's the key part. Take the log on both sides. When you take the log on both sides, okay, that allows you to use the power rule. This is the next key step. That means that exponent comes from here, comes down on the line, times the log of 1.03. Divide both sides by the log of 1.03. So you've got 2 divided by the log of 1.03. Now, I don't have the nitty-gritty details here, sorry, but keep in mind you get your first number. Whatever the log of 2 is, put it in the denominator where the log of 1.03 is. This is your second number. Then do the division to finally produce your answer of 23.5. Okay, so you should be able to do that on your calculator to confirm all that. And you've done it. Okay, so Mr. Q, I'm just going to quickly go through this here. We have done page 5. One more page, our grand finale here. And I will see you for page 6 in a couple minutes. Until then, if you get a chance to do some of these extra credit problems, some of them aren't too bad. I just would not recommend that you spend too much time on it. So manage your time. Okay, take care, and I'll see you for page 6. Bye.